So welcome back to the next session of the LIPES workshop. So the coming session will now be dedicated to the demo plant design at the heart of the LIPES project, with a focus on mixing technologies. So I will now be handing over to Patrick Jobst from STC Engineering, based in Germany. So Patrick, the floor is yours.
Thank you, Jan. Hello, everybody. I will start my presentation now. I will share it. Here you see it. Yeah, my name is Patrick Jobst. As Jan told you before, I'm a project engineer from STC Engineering based in Germany. And yeah, in this presentation, I will show you what we as STC Engineering do during the LIPES project. Our main focus was the design of the demonstration plant, and we were part of the people who was responsible for the general plant and equipment design. As specialists for mixing equipment, we are focused on the development of the necessary mixing equipment during the project. So the table of contents for my presentation: in the first part, I will show you what STC does and what are our specialties. The second part is more or less the key part of the presentation. I will show some details about the general plant design. The third part of the presentation is a travel through the past of the project till the present status of the plant. I want to show you how we changed the character of the plant. In the last part, there are shown some parts of our ideas for the agitated systems in this project. The STC Engineering GmbH and engineering company was founded in 1995. It is existing in two companies. One is the engineering company. It was founded at first, and later we founded the GmbH for the delivery of hardware because the customers wanted this from us. The central focus of the company is on mixing technology, and we have, together with all employees, an experience of more than 30 years in the mixing technology. Our main field is, and we are strong in heavy mixing units and special agitators. And we are able to deliver the agitators for the most mixing tasks worldwide. And we are also able to engineering and deliver customized skids and small plants. Here you can see it: the agitators, the vessels and reactors, mixing machines, and also package units. For the LIPES project, our main part was the engineering. We have different fields what we do for the engineering, and 5 of them are the construction and process design. For example, we can do the agitator design, the general plant design, mechanical design of vessel and agitators, or different design parts for plants, for example, piping and pumps. Another field is the risk analysis. We are able to do vibration analysis with the finite element method, some load analysis, or for example, wear and tear analysis. We are also able to perform video animations, for example, to show the procedure of assembly and disassembly, do collision considerations, or do the visualization of stress and vibration. We are also able to elaborate some technical documentation, for example, for the ATEX or the CE conformity certificate. Together with partners worldwide, we are also able to provide certificates for worldwide application and standards. The last point is that we can do some tests. We are able to perform tests in our own small laboratory setup, or it depends on the project, together with partners. For example, the University of Applied Science in Köthen, Anhalt, Germany. The tests that we can perform are, for example, performance tests or mixing time tests, or tests to determine the perfect impeller selection, for example, for applications in steering of solids or dissolving. That's not the only part of our service, but that's the most relevant part. So after that, I will come to the general plant design. The picture you see is not the status at the beginning of the project. It is more or less the final plant design, except the latest changes. We designed the plant together with our partner Oleon according to the basic requirements of the process. We use the existing small plant to show how the process works. To extend the place for the plant, we used an area outside of the plant building to integrate a storage area. You see it here. The storage area is for handling the whole process in this one reactor design plant to guarantee a 24-hour process for demonstration. The membrane unit is here, is for separating the enzymes after processing from fluids inside the process. The enzyme preparation is for generating a solution with the enzymes to transfer them through the process. You see it here in this corner. And the main demonstration reactor here, with a size of approximately 4,000 liters, is the heart of the plant. The enzymatic process takes place in this reactor and generates the product. There is a central piping route between main reactor and storage area to guarantee the necessary flow of all equipment. Here at the back. In the next slides, I will show some details of the plant. The pumping area below the main reactor is for guaranteeing the transfer between main reactor and storage area. The transfer between enzyme preparation vessel and main reactor will be performed by pressurized air. The difficulty for the step was the integration of the equipment into the existing plant to guarantee that the space for the equipment is enough. See it here, here, and here, the enzyme preparation pot. The storage area manages the main fluids of the plant and provides the input for the main reactor. Additionally, also the output of the reactor will be stored here and can be transported easily to the next step, process steps, at the other partners for the plant. Also, the membrane unit is placed at the storage area due to the limited space in the existing building. The membrane unit owns one of the main topics of the process to guarantee the recycling of the enzymes and to use these enzymes again for the process. The membrane unit is able to have an internal circulation loop or to be part of the circulation from the whole plant. Here you see the membrane unit, here the storage tanks and the pumping skids, and here the piping route into the main building. This very special area of the plant, has no function regarding the demonstration scaled plant itself. It is a 200-liter reactor skid, which is a part of the existing plant and also part of the process development of the LIPES process. At the first stage of the LIPES project, we used this reactor for process development in smaller scale and later to validate some test results. This reactor is also integrated in the whole plant and it's able to communicate with the storage area as well as the membrane unit and the enzyme preparation vessel. This was in general a short plant design description which shows the idea of the demonstration plant and a 3D model which shows how it has to look in reality. Now I want to show you the way from the existing plant to the plant it should be, or more precisely is now. We have started our LIPES project with the idea to use an existing fabrication plant with a fermentation reactor as key equipment as basis for the demonstration plant. The plant location is Venette in the north of Paris in France. Here you see the existing key equipment. It was a 4,000 cubic meter main reactor, a 200-liter reactor skid, and a skid with a 50-liter agitated vessel. The reality was that the plant was very old and some adjustments were done during all the time. We didn't have any information of the current plan layout or function. And so at first we had to create documents and drawings about the existing plan to understand what is possible. This understanding was mandatory for all first steps. We had to know which function each pipe has and which pipe we can maybe use for our LIPES process. That was a difficult part, which needed a lot of time. The result of this was on the one hand, this 3D model, and on the other hand, a piping and instrumentation diagram of the existing plant. Based on this information, we are able to start our work to design the new demonstration plant. In the following slides, I will show some pictures of the 3D model compared with the reality of the existing plant. On this picture, you see the main reactor of the existing plant. This reactor will be the heart of the LIPES demonstration plant and has been adapted for the LIPES project. We need some special equipment inside the tank for the LIPES project, and also the drive unit needed an update. This picture shows the 200 liter smaller reactor, which is important for the process development of the LIPES process. You see it here. It was difficult at the beginning to understand this cryptic bunch of piping, but with the background that it is a fermentation reactor, we realized fast that this piping is for supplying the fermentation reactor with clean air and for supporting the heating jacket with hot or cold water. So at the end, it was easy to understand this part of the plant. This part of the lower area of the plant directly under the 4000 liter main reactor. It includes also the system for heating and cooling of the reactor. Check it, and you can see the drive unit of the bottom entry agitator here. There is also the possibility to connect different piping to the plant with this piping racket. On the next slide, I will start to show what we changed at the plant to become the final demonstration plant. The main work on the erection of the demonstration plant was the storage area. We had to perform a lot of civil work to guarantee that we have a suitable roof and floor to install the storage area. You can see on the pictures the different storage vessels. We use standard IBCs for that. Also, you can see the pumping stations which perform the flow between the different stations of the plant. We designed each pumping station very similar to others to simplify the plant direction. Also, a lot of piping work was done during the installation of the storage area. Here you see the pumping stations, for example. Additionally, we installed a new membrane unit as one of the key equipment of the plant at the storage area. This unit is a complete pre-installed unit which was delivered by a specialized partner for this project. It was developed according to the large amount of tests to gain the best possible performance for the project. You see it here. On the right side, the new agitator for the enzyme solution preparation vessel is shown. The existing one was an old vibration mixer, which was not in best state and not suitable to prepare the enzyme solution. Inside the plant building, we have included 2 pump skids, which transfer the fluid to the storage area. These skids have been erected between all the existing equipment of the plant. The pumps are designed for a wide range of products because the LIPES project process is based on different input products. During the project, the storage area was extended due to capacity reasons. This happening during the pilot process development process with the 200 liter smaller reactor. We needed also a special vessel for one central process step because a standard IBC wasn't suitable for this application. Also, the membrane system was tested with the product of the smaller reactor. Here you see the special vessel and also the membrane unit. On these pictures, you see the piping work we have done. It was very difficult to install the new piping because there was a lot of existing piping work. Due to the good preparation of this work with the 3D model and the design work, it was at the end not the biggest issue we had. Additional to the new equipment and piping, we installed a complete new control system which allows us to have perfect control of the process and to know at each time what happens inside the process. For this, we have installed also a lot of measurement equipments. Here you see the piping and the part of the control unit. When we switched the process from pilot stage to demonstration stage, we saw that the amount of one IBC isn't enough in our storage area for a full day process. So we did decide to extend the storage area so that we are able to show that the process works also in a longer time frame. We rebuilt the storage area and add also some civil structures. You see it here, the complete new build storage area. Now I'm coming to the last point, referring the progress during the project. Here, the current status of the plant is shown. You see that we have finalized the rebuild of the storage area. We added, for easier handling of the product, a weight station for the initial filling of the reactor. All other components of the plant stay in the same way as shown before. Here, a perspective of the actual main reactor is shown. Now, for the last step of the LIPES project, a stable production process on the demonstration plan, we are perfectly in line with the requirements, and there's hopefully no need for adaptation of any other part of the plant. You see additional on this picture, I forgot to say, the control panel of the whole plant. See it here. On the next page, we come to the last part of this presentation. In this last part of the presentation, I want to show you some aspects we thought about in this project due to agitated systems. You see in the graphic that we have a very large range of scale-up work in this project. What we are not showing is the next step after the LIPES process, the development of a production unit which uses the process of the LIPES project. The main reactor of this production unit will have more than 40,000 liter volume. It's right from the demonstration reactor. We started this project with a very small 1 liter scale to perform the first tests. After that, we built together with our partner Oleon a 5 liter scale laboratory plant to see if the process will work in principle. That was the preparation for the LIPES project. Inside the LIPES project, the first step was a 13 liter scale. For this scale, it was a topic to bring the requirements we have based on the 5 liter scale together with the existing equipment we have for the larger scale. The main issue for this was a geometrical issue. The last two steps belonging to the scale up in the LIPES project was the 200 liter and 4000 liter scale, which I presented before during the principal plant layout presentation. An important issue for the layout of an agitator is the correct impeller. The impeller influences the performance of the agitator. So we think about what will be the best possible impeller for the LIPES project. We have checked all the possibilities that are relevant for the process in the LIPES project. On this page is shown some of the possible impellers. In principle, the impeller can be split into three groups. The tangential one with an anchor or, for example, helical ribbon. The radial one, for example, with a Russian turbine. And the axial one with, for example, a pitch blade turbine, a standard propeller, or other ones. There are some very special impellers which can possibly lead to integrate in one of these groups, but they are not very common, and so we separate them in our overview. These are something like this, for example, a coaxial impeller or a gassing impeller. At the end of this process, we decide that we will test at least 3 different impeller types for the LIPES project. The Russian turbine as a radial type and the VHFI impeller as an axial type. Additionally, we checked also the Maxplan impeller, a special designed impeller from Asia, to see how efficient it is for our process. At the end, we decide for the Russian turbine, because a radial impeller seems to be the best option for the specific requirements of the LIPES process. Additionally, the Russian turbine can be used as a multi-stage impeller, what means that we use currently 2 or 3 impellers in the reactors. This is not possible with the radial pumping max blend impeller. And minor reason was also that in the existing reactor of the plant, there are also Russian turbines already installed. Here you see the existing impeller types and sites of the 2 reactors. With this configuration, we performed the LIPES pilot and demonstration trials. You see that there is a 3-stage Russian turbine installed, and we have already baffles inside the vessel. A quite common installation. A very special point of this project was the optimization of the flow inside of the vessel. For a part of the project, we need to avoid the backflow between different product zones inside the vessel. For that application, we developed a special chamber system which can be used for that topic. You see the pictures, the chamber system of the 5-liter laboratory scale and the 200-liter pilot scale. Here the pilot scale and here the 5-liter system. It's also designed for the 13-liter and 4,000-liter scale. At the end, I will come to the conclusion. SCC Engineering performed the work on the general plant design of the LIPES project successfully. We additionally have an overview on the whole erection process of the plant and do together with our partner Oleon take care for a good working plant. During the project, we also worked on the mixing tasks inside the new LIPES process and optimized them to produce the best possible product at the end in the demonstration plants. Thank you very much for your attention. I hope this excursion through the plant design part of the LIPES project was a remarkable topic for you.
So thank you, Patrick, for this interesting and nicely illustrated speech. I've got a couple of questions for you. The first one would be, what was, according to you, the biggest challenge that you met during the plant design of the LIPES project?
I think the whole project was a big challenge and a complete new kind of work for SCC. We have never worked before on such a big project with partners all over Europe. It was an issue for us also to design the new plant on the existing plant in France without any correct documents. But as you can see before, we mastered this challenge and elaborate a good basis for the demonstration plant.
Okay. And so more generally, could you give us a bit more details about the kind of services or analysis, that STC can offer in typical projects?
We are able to offer a wide range of possible analysis. I think our main part in this field of engineering is the FEM, the finite element method analysis, to analyze mechanical strength of constructions we designed. And it's also possible to evaluate the vibration of a system we design. For us, this is the most important, or it is the most important to see how an agitator is vibrate together with a vessel as unit. That is sometimes very interesting when you see the small changes, for example, to exchange a flat gearbox into a pivot gearbox, have a quite big impact for the vibration aspects. Additional to the FEM analysis, we are able to perform the CFD, the computational fluid dynamics analysis. This analysis helps us to understand the process much more deeper, and we can see how an agitator generates his flow field and in which position the, for example, the heat transfer is good or bad. And on the other field of analysis, for example, the wear analysis is one of our things we can do, where we take a look on broken impellers or other agitator parts, and we conclude which is the reason for this wear of the impeller or this broken part of the agitator. I think also other analyses are possible, but I think also this extends the length of this presentation too much, and yes, the people or you can contact me personally to go more into detail.
Okay, well, thanks again, Patrick, and thank you all for watching today. Don't hesitate to leave us a comment, a question, and we'll get back to you through the website. Thank you.
Thank you too.